In this video, we will be learning how to name ionic compounds that are hydrates. This continues our learning objective for learning how to name chemical compounds. So what are hydrates? Hydrates are compounds that contain water molecules. You can think of them as a sponge that can absorb water, but water can also be removed from them. The word anhydrous is an adjective to describe a compound that has had the water removed. Anhydrous compounds usually absorb water from the air, and so they need to be stored carefully to prevent them from doing that. If you're familiar with your gemstones, opals are actually hydrates of silica, which is SiO2, silicon dioxide. And that has a varied number of water molecules as part of the structure. Epsom salt is another example of a hydrate. So if you go to the pharmacy section and buy Epsom salts for salt baths or whatever, you can look at the packaging and it says magnesium sulfate heptahydrate. It can also be Epsom salts can also be used as a laxative. So how do we name our ionic compounds that are hydrates? We will only be naming hydrates of ionic compounds. We will name the ionic compound first and then indicate the number of water molecules attached to the structure. So this diagram here shows the ionic compound made out of sodium ions and thiosulfate ions. And if you look carefully, you can see the water molecules creeped into the ionic compound's structure like a sponge. So we have to name the ionic compound first. So this is sodium. That's my thiosulfate ion. Sulfate is SO4 2-, and the thio prefix means that there's a sulfur substituted in for one of the oxygens, but the same charge. Now we put a dot, which is like glue, not multiplication. So that's a little dab of glue there. And it's holding those water molecules to the ionic compounds. Now we have a number out in front to indicate the number of water molecules. This table here shows us how many water molecules we are and what prefix we use for that quantity. It goes mono, di, tri, you can think of triangle. Pent, you can think of pentagon. Hex, you can think of hexagon. And no one remembers 7 or 9 very well. Oct, you can think of a stop sign. And I'm not going to try to draw a 10-sided shape. That's just hard. For number 4, you can think of Tetris, which had a series of 4 cubes. So tetra is like Tetris. And so hopefully that can help you remember our prefixes. You should try to remember 7 and 9. It's just that those are the ones that people typically forget because the shapes aren't used in geometry very much. All right, let's fill out the missing areas for this table as a practice. Go ahead and pause the video and try to apply what you've learned to solve this problem, and unpause the video when you're ready to continue and double check your work. All right, let's go over this. So if we have a cation of NH4+, that is ammonium. That is an polyatomic ion known as oxalate. So that's ammonium oxalate and 1 water molecule. And so that's monohydrate. I was writing too big. All right, my chemical formula, I will need 2 ammoniums to cancel out the charge on my oxalate. I needed 2 of those, so I put that in parentheses, but I only needed 1 of those. So that's no parentheses around it. And then I'm not going to write the coefficient of 1. I'm just going to put H2O. All right, for our next one, we have to work backwards to come up with what the name of it is and what the ions are. I can see my polyatomic ion acetate, which is C2H3O2 with 1 minus charge. And that is sodium. Sodium's in group 1, so it's a +1 charge. And there are 3 water molecules. So that's going to be named sodium acetate trihydrate. Remember, if you're well hydrated, you are drinking water. All right, for our next one, let's work out our chemical formula. Oh, it says copper 2+. So it's telling me that I have copper that has a 2+ charge. Chlorine is in group 17. It's a halogen. And so it has a -1 common ion charge. Hexa means 6. And so I have 6 waters. So now I can write my chemical formula. I will need 2 chlorines for every 1 copper, and I will need 6 waters. Now I need to name my compound. That will be iron. Iron has a charge of 3. PO4 with the 3- charge is phosphate. And it needs 4 waters, so that's tetrahydrate. Now that should be one word, I just didn't have enough room. Now for my chemical formula, I will need 1 iron and 1 phosphate to be neutral. And then I will need 4 waters.